заканчивается очень большой и очень важный этап работы, связанный со строительством мостового перехода на остров Русский. Такие объекты, когда они возводятся в регионе или в стране, они, безусловно, по факту становятся символами, одними, во всяком случае, из символов и регионального масштаба, и общенационального.
The closing panel of the longest bridge channel span in the world was installed in April 2012. The stay cable bridge over the eastern Bosphorus Strait to the Ruski Island in Vladivostok has the world record-breaking channel span that is 1,104 meters long. The longest stay cable measures 580 meters. Today, it is the stay cable length limit for bridges of this type. The bridge is more than 70 meters high above the water level. The pylons are 324 meters high. Construction started on September the 1st in the year 2008. The commissioning is scheduled for July 2012, just in time before the opening of the APEC summit. Prolonged rains, fog, and strong winds that were sometimes gusting at up to 36 meters per second have been challenging the bridge builders. Storm advisories were issued 64 times during the first 170 working days, but the inclement weather could not stop the work, which has been going on day and night. The temperature in winter dropped below 30 degrees minus, and in summer it was up to 37 degrees hot. It was hard to bring personnel and supplies to the Ruski Island all the time because of high seas or heavy ice conditions in the eastern Bosphorus Strait. In certain periods, the ice was up to 70 centimeters thick. Two production facilities ensured the non-stop flow of supplies and seamless work processes. One production facility was located on the Nazimov Peninsula and the other on the Ruski Island. A rebar and welding workshop, a facility for steel span structure module assembly, building laboratories, woodworking, mechanical, and repair workshops were located on the mainland. Storage facilities, vehicle parking lots, berths, office buildings, living quarters, catering facilities, and 4 state-of-the-art concrete mixing plants from Tequil Oy and compactors were put in place on both shores of the strait. Over 1,300 meters of new rail tracks and raised ramps for receiving bulk materials were built on the Nazima Peninsula for delivery of steel structures and for supporting non-stop operation of the concrete mixing plants. For the same purpose, a berth was built and aggregate stowing grounds and water tanks were put in place on the island to ensure the non-stop delivery of supplies. About 320 pieces of state-of-the-art special equipment were used in construction of the bridge to the Ruski Island. Unique 40-ton and 20-ton Kroll tower cranes, which grew 340 meters high by the end of construction, were used for erecting the pylons. 1,350-ton Liebherr crawler crane was installed within a record short time for lifting the first 10 sections of the steel span deck on the Ruski Island. The same crane has lifted a Russian-made derrick, which was used to install the remaining sections of the channel span structure. Viaducts of the total length of over 900 meters provide approach to the bridge. The viaduct piers are made as columns that are from 9 to 30 meters high. The viaduct span structures are made of box-shaped members with inclined webs, which are attached to a cast-in-place reinforced concrete slab. The bridge piers, M1 on the Nazima Peninsula and M12 on the Ruski Island, are the heaviest and most complex structures. They take up the horizontal load from the cable-stayed span stiffening girder. A small man-made peninsula was rock-filled for pylon M6 footing borehole drilling on the Nazimov Peninsula. The pile footing for M7 pylon on the Ruski Island was built from the water using a temporary steel eyelet, and a small man-made peninsula was rock-filled after the drilled piles and closing sheeting had been completed. Drilling and pile concreting operations were conducted from the water at sea for the first time in bridge building in Russia. The water depths in various areas of the operations varied from 14 to 20 meters. A total of 1.5 million cubic meters of rock and dirt were moved for building the construction sites on the Ruski Island and Nazimov Peninsula. When construction has been completed, the small peninsulas will protect the pylons against impacts of vessels of up to 66,000 displacement tonnage against ice drift and waves. 120 drilled piles, each 2 meters in diameter, have been put in place to build the footing of each pylon. Permanent steel-cased piles under M7 pylon have been sunk 46 meters deep. The depth of the reinforced concrete piles on the mainland is up to 77 meters. The builders used self-compacting B35 grade sulfate-resistant Portland cement concrete for erecting bridge pier and pylon grillage. The concrete will efficiently protect the footings against corrosive fluids and prevent rebars from getting rusty. It took about 20,000 cubic meters of concrete mix and about 3,000 metric tons of steel structures to erect the grillage for each pylon. This was the most labor-consuming and critical operation of the bridge construction project. Strain gauges are embedded in the grillage body for monitoring health condition of the giant footing. The pylon bodies were erected using B60 grade concrete. Custom-made self-lift shutters were used for pylon concreting. Shutters that had 7 working tiers of the total height of 19 meters allowed the preparation of the construction joint, reinforcing, concreting, concrete cure, and finish to be run simultaneously in 3 sections that were each 4.5 meters high. The shutters were moved by hydraulically powered lift module. The self-lift shutters cut down the cast-in-place reinforced concrete structure erection time by a factor of 1.5. This was a significant time gain given that the total scope of concreting for each pylon was over 20,000 cubic meters. The navigation span stiffening girder is of an all-metal design. It is made as an integral box that makes up the entire cross-section with orthotropic plates at the top and bottom and with a system of transverse diaphragms.
And then we try to run at 52 meters per second, 10 to the 8, it's 5 times stiffer.
A girder model has passed the strength and wind load tests in an aerodynamic test laboratory in Denmark. The span structure model withstood the maximum wind velocity and all potential combinations of airflows. The steel stiffening girder consists of 103 main panels, each 12 meters long and 26 meters wide, and 2 6-meter-long transition panels. The panels weigh a total of 23,000 metric tons. The stiffening girder is 1,248 meters long. The panels were delivered to the installation point by barges and were then lifted to the height of 70 meters. After the section number 20 has been installed, paired panels that were 24 meters long were delivered for installation to expedite installation of the steel stiffening girder. The panels were pre-assembled at the production facility on the Nazimov Peninsula and at Nakhodka shipyard. This ruled out additional operations of fitting the heavy tonnage panels during installation, which was conducted under strong winds. Installation was expedited, and the first-class rated welded joints that had to pass ultrasound examination had a better quality. An improved stay cable system with a higher strand density within the jacket was used for the bridge over the eastern Bosphorus Strait. The stay cable system weighs 3,720 tons, with a total length of over 54 kilometers. The stay cables are composed of 13 to 85 parallel, individually corrosion-protected strands. Each strand consists of 7 galvanized steel wires enclosed in high-density polyethylene sheathing. A compact cable configuration using a small diameter jacket reduces the wind load by 25 to 30%. This reduced the usage of materials for erecting the pylons, stiffening girder, and footings. The stay cable jacket is made of 2 plies, the inner layer of black high-density polyethylene, and the other, thinner layer, features the Russian national flag colors. The ornamental jacket has a helical groove for the protection against vibrations under combined exposure to rain and wind. The comprehensive mechanical protection and quality monitoring throughout the fabrication of all stay cable components ensure high strength, durability, and corrosion-resistant indicators. The stay cable design service life is of at least 100 years. The bridge construction has attracted numerous visitors and specialists from the very beginning. Government commissions, foreign delegations, and journalists could be seen on the project sites practically every month. When construction has been completed, the Vista platform will be open to the public, and the bridge to Ruski Island will become one of the most important landmarks in Vladivostok, a logo for the city, for the country, and for the SK Most group of companies.